Hey everybody, Peter Zeihan here, coming to you from snowy and melty Colorado, where our first 3 feet of snow is rapidly going away. Anyway, today we're talking about something that happened last weekend, the 9th, 10th of November, and then followed up by an event on the 11th. The 9th and the 10th, the Taiwanese semiconductor company, TSMC, which is the company that makes all the high-end semiconductors in the world. If it's going to go into an EV, a high-end phone, a high-end computer, satellite communications, or artificial intelligence, it comes from TSMC, their foundries. Anyway, they said that they are no longer going to even take orders for anything that is 7 nanometers or smaller from any Chinese entity whatsoever. The instigating issue was a couple weeks ago in a Huawei product. Huawei is a Chinese telecommunications firm. They found some TSMC chips in one of the product lines, indicating that the sanctions as they currently exist are not working as well as some people thought that they might, and some products are still making it to China and getting incorporated into products. And so TSMC has announced that they're just not even going to take orders from the Chinese for anything that is at 7 or less. 10 is generally considered to be the line where you get into the really high quality stuff, and all the really good stuff that goes into stuff like artificial intelligence tends to be 4 to 3 or even less. So we're talking about not just the top tier here, but like the second one in. And within 48 hours, the Biden administration announced that they would be leaning heavily on TSMC to make sure that no Chinese orders were ever even successfully placed. So the Taiwanese announced compliance before the American order even came down, which gives you an idea of how willing they are to cooperate on this issue. I'm sure that order was being drafted before TSMC made their decision, but TSMC beat them to the punch. A couple things come from this. Number one, we have our first foreign policy crisis for the incoming Trump administration. The Biden administration is setting them up for a pretty good success for relations with TSMC, but we've had a difference of style when it comes to Trump versus Biden when it comes to China. The Trump position has been tariffs, but absolutely no meaningful enforcement. And so it's become a fun little game that they really enjoy in China for finding creative ways to get around the tariff structure, either by mislabeling things or getting around rules of content in NAFTA, or basically putting a stamp in a third country like Vietnam and then shipping it on. And overall, it's been pretty successful. Trump is good at making this presentation. He's good at making this statement, but he's never really been very good at the follow-up. The Biden administration has taken a much more surgical approach, identifying specific sectors and then building tech walls around them to prevent tech transfer. There are pluses and minuses to this strategy as well. Requires a lot more technocracy in order to work because people have to go through and evaluate not dozens, not hundreds, thousands of supply chain steps to make sure that the appropriate products are not going where they're not supposed to go. And it also requires a lot more cooperation with the allies than just doing tariffs. So it's not that either of these are right or either that these are wrong, but they require different institutional lineups. Biden is a bigger believer in state power and the rules of using the bureaucracy and the skill set that was within to achieve ends, whereas Trump provides to just make a big flashy statement and then move on. The correct answer, if correct is the right word, is probably a hybridization of those two. And now that is going to be on Trump's desk on day one to figure out what he's going to do with it. So that's kind of piece one. But now let's talk about the second problem or issue, and that is the technological threshold that TSMC is attempting to establish as the barrier, that 7 nanometer range. 7 nanometers is about the difference between what you can theoretically achieve with something called deep ultraviolet, which is an older lithography technology, and extreme ultraviolet, which is the new one. But first, it's best to explain a little bit how this works. When you're making a semiconductor, your first step is to grow a crystal about the size of a Volkswagen. You get a big pool of melted silicon oxide, you put a seed crystal on it, and over the course of days to weeks, you draw it up, growing a crystal that's just this huge ingot. And then you slice it laterally into wafers. You then take those wafers, you dope them, you bake them, and you etch them under a lithography machine, and you do that over and over and over and over and over until you get what you're after. Now, if you're using deep ultraviolet, you're using EV radiation light to basically etch it. The problem with DUV is it can only be so specific. It can't go down to the atomic level, and it requires a lot of hands-on engineering in order to operate. So human error is always there, and even if there's no error, one engineer is going to do it a little bit different than the next engineer. In addition, you have to make some basically manual adjustments to each machine, and so each machine is going to be running different product sets, even if they're using the same design specs. And so you get a lot more wastage, you get a lot more chips per wafer that just don't work. Extreme ultraviolet is a technology developed by ASML, that's the Dutch lithography company, to get around these problems. It uses a much tighter focus, and in doing so can get almost down to the atomic level, and so you can get down below 7 nanometers. Also, it's a more automated system where you plug in your programs to one machine and you can just copy it to other machines in your fab facility, and humans are for the most part not in the loop except for things like maintenance and oversight. So you get a higher success rate, you get fewer errors per semiconductor, and all the semiconductors that come out of the entire fab are more or less identical. So there's an efficiency issue, there's a superior performance issue. And so all of the really good chips that we want for things like artificial intelligence and electric vehicles and your iPhone are all made using EUV, whereas DUV can be used to make chips usually in the 10 nanometer to 90 nanometer range that can go into a much wider array of factors where you don't need as much memory or as much processing power or parallel processing capacity. Until recently, we thought that DUV really couldn't go past about 10 or 12, but the Chinese have proven that if they really want to brute force it, they can make it go down to 7. And Huawei came out with a phone about a year ago that used a 7 nanometer chip that came out of a DUV process. Huge power hog, very expensive. The price of the chip per computation was among the highest on the market, but they were still able to do it, and that spooked some people. So what is happening here is we're seeing a coalition of the Dutch, the Japanese, the Koreans, the Americans, the Taiwanese to draw a line at EUV technology. Because if the Chinese can't get into it, then all of the cutting-edge technologies of today are beyond them. And all of the cutting-edge technologies of 7 years ago are beyond them, because there's a hard limit as far as you can go with DUV. The real limiting factor, though, honestly, isn't the fab facility. It isn't TSMC. I mean, yes, not taking orders is important, but the real issue is labor. The Chinese lack the ability to make a DUV machine, much less an EUV machine. And EUV machines are only made by the Dutch, only made by ASML. So right now, unless they can get a hold of the machine and the labor necessary to maintain it, and the software necessary to run it, the only way they can get these chips at all is to somehow get ones that are already made for someone else. So the only way that the Chinese can achieve technological breakthrough in this sector now is basically to hijinks this stuff from someone else's order. And it's hard to imagine them doing that at sufficient scale to actually have products. So this will land on Trump's desk on day one, how to pursue this sort of technological blockade, how to do it in league with tariffs or something else. And I must admit, I'm kind of curious how that's going to shake out.